Now, one other thing to keep in mind when you're working with these linear equations is that you can always get rid of any fractions right up front. If you keep in mind what we did for rational equations, we just need to multiply by the least common denominator. And that's going to make these things much easier for you to work with, whether it's solving by graphing or solving by substitution. So just to look at an example of that, I did one for you in the notes, but just to look at one that's actually in Hawks. If I were solving this system of equations, and again, to do graphing, I need to solve each one for y first. The first thing I would do is not try to start solving for y. It would be to clear those fractions and get rid of the denominators. So my first equation here, 7 over 15x minus 1/5 y, and this is equal to negative 4 over 5. So my denominators here, I got a 5 and a 15. My least common denominator, or my least common multiple, would be 15. And so before I even think about solving for y, I'm going to multiply everything by 15 so that I am not having to work with everything in terms of a fraction. Now, when I carefully simplify here, right, 15 divided by 15, that's 1. So this is just going to leave me with 7x. Here, divide by 5. It's going to leave me with 1 on the bottom, 3 on the top. So this will become minus 3y. And then over here, divide by 5 again, 1 on the bottom, 3 on the top. And that's going to become negative 12. So now I have something that's much easier to work with. Now again, what I want to do here is I want to solve it for y because I need slope-intercept form to graph it. So at this point, since I don't have any more fractions, I can see if I want to get y by itself, the first thing I would need to do is subtract the 7x. So we would have negative 3y is equal to negative 7x minus 12. And then to get y by itself, I would divide everything by negative 3. All right, we got to take that whole coefficient. And so that will give me slope-intercept form. Y equals, now, negative 7 over negative 3, that becomes positive 7/3. That's my coefficient of x. That would be my slope. And then negative 12 divided by negative 3 is going to be a positive 4. So my slope-intercept form is what I'm going to use to graph. So right in here, I'm going to have 7/3 times x. My y-intercept is at a positive 4. So I've graphed my first line. And now I'm going to do the same thing to the second, right? The second equation, 7/6 x minus 1/2 y. And that is equal to a negative 2. So my denominators are 6 and 2. My least common denominator or my least common multiple would be 6. I'm going to multiply that through to get rid of my denominators. This will become 7x minus 3y, and 6 times negative 2 is negative 12. And then same thing. Now that I've gotten rid of the fractions, I just want to solve it for y, get y by itself. So if I, oops, sorry about that, that should be subtract 7x from both sides. This becomes negative 3y is equal to negative 7x minus 12. Divide everything by negative 3. And my slope-intercept form, y is equal to 7/3 x plus 4. Now this should look familiar because that's the same thing that happened when we solved the first one for y. And so what that allows me to do is see that I actually have identical lines. All right, this one's also going to be 7/3 x with a y-intercept of +4. And so I can see here in my graph, these are the exact same line, so they intersect at every single point on the line, which is why this is the case where we have an infinite number of solutions. And I do want to mention to you here, when you're in Hawks, if you go to the tutor and you look at the solution, they do not typically clear the fractions first. So I wanted to make sure that I pointed that out to you because I think it makes it a whole lot easier. And this is something that we're familiar with because we just did rational equations. So even if you're not seeing that happen in Hawks up front, I would strongly encourage you, if it's fractions, to multiply by that least common denominator and clear those fractions out first.